So now that we understand the mechanics of inheritance, let's make a few comments about what we've done. There are four things we can do with an inherited method, or perhaps more, in which you can choose what you're doing with your subclass. First off, you can simply inherit an implemented method. If you've done something in a superclass and the subclass doesn't need to have anything different, then okay, you just don't override it. You leave it there. So for instance, we didn't make new pay methods for our different types of employees, so great, that's fine. Everything still works okay. You should not do this if it's an abstract method, because otherwise, you'd see, as you see in our example, you get an error typically, which means that anytime you have an abstract method in your superclass, you should implement it properly for your subclass. Another thing you can do is override an abstract method to implement it. So if it is abstract, actually override it and write the functionality in there. So in this case, get monthly payment, which is abstract because it just raises an error if you try to call it from the superclass alone, needs to have an implementation in any subclass of our employee class. We can also override an implemented method to replace it. So if you suddenly decide, the way that we calculate, the way that we do paying is not great, you can make a change to that too, especially in the case that your subclass requires a different kind of behavior. For instance, let's suppose that, we decided we hate all salaried employees and they don't get paid. So instead, you can define your new pay method in here, and instead of calculating and printing how much you get paid, you just laugh at them cruelly and evilly, and this would work and correctly deny you anything. Finally, we can override an implemented method to extend it. So sometimes you want what's already there, but you want to do some other things as well. In other words, you want to extend the behavior that is inherited. We saw this in our initializers already, where we called the employee initializer to set up things that were common for everybody. So rather than repeat the code, we call it as a helper, and then it does stuff that's already there for us. We don't need to duplicate the code a second time. And then we add some additional stuff to set up, for instance, our salary. You can extend any method, not just initializers. So here's another example. Suppose at pay time you want to print out two messages, one from employee and one from salaried employee. Since we already have a superclass method that does some of the work, don't need to copy the code from that. We'll just call the method as a helper rather than repeating it. So here we'll do this. Salaried employee. We're going to copy, or I guess I'll just copy the method here, the pay one. We'll chuck that into here. And we'll make a call to pay Freddie. I think I need a date, right? Yeah, I need a date. Grab a date there. All right. Set up everything. We've seen all this already. Initialize our stuff. Cool and good. Okay, and now we're going to pay Freddie. So remember, method resolution. Where do we go to see who gets which method we call? Well, Freddie is a salaried employee. Does salaried employee have a method called pay? It does, because I just added it. So that's the one we're going to go to right here. All right, our new self is Freddie.Lowndes, or Freddie Lowndes. Here's our pay date. And the first thing we're going to do is directly call the superclass's version of pay. So as a helper, and so we're going to open a second frame here, and that has pay as the name, and this is going to do the normal pay stuff, and then we get the thing. Great, good. Employee was paid, and then we print payment accepted. Have a nice day. So great, we have two payments. Isn't that cool? Our use of inheritance allows your client code to do the same thing for all the types of employees. So here's another example where we go through a list of employees and we pay each of them without having to, assess what kind of employee are we dealing with. So here we set up 3 employees. We got Fred, Barney, and Mr. Slate. They are 3 different kinds. And we can do for E in employees. So E is, because this is a list, we can just iterate through, and E is the name of each of them. And we don't care what kind of employee E is. Each one has a method to allow them to be paid because they've been defined so in our employee class. So we can do e.pay all in the same date, and they will all use their respective pay methods to go through things. Recommend you give this one a shot and walk through the steps to make sure you understand. In other words, clients can write code to an interface that's defined once in the abstract class to make it work for any subclass, no matter which kind, even if there's ones we haven't thought about yet. This is really good because it means that you would need to have an if statement to check your type of employee in here and make things real messy and complicated, if not for the fact that you can just simply pay an employee, regardless of their type. So we say that the employee class represents the shared public interface of our two subclasses. And so the public interface is the way client code interacts with the methods and attributes. It's shared because it's common between hourly and salaried that you can, do e.pay. And we say that class employee is polymorphic to signify it can have different forms. An employee could be a salaried employee or it could be an hourly employee. Now, the employee class is abstract. We should never make one. Does that mean it's useless? Well, no. We've seen that it has the shared public interface that we can rely on and thus supports polymorphism, the idea of having these subclasses. Furthermore, polymorphic code can continue to work even if we add new subclasses. Employee is also useful in a second way. If someone decides to write a new subclass for employee, for instance, getting commissions, that get monthly payment needs to be implemented in some way. In other words, you have to support the shared public interface that client code is going to count on. And in other words, by having this abstract method here, you can guide people who are trying to make new subclasses into realizing, oh, I need to write code for this in a certain way. We've seen some benefits of inheritance, but it's not always perfect. Don't forget there's another kind of relationship between classes we've seen, composition. So to represent people who are car owners, a person might have an attribute car, which stores a reference to a car, but we wouldn't use inheritance for this. Unless we're like in Transformer world or something, people are not cars. Or I guess the movie Cars, but even then I have some skepticisms. Composition is thought of as has a relationship, like a person has a car. Inheritance is a relationship. A salaried employee is an employee. This is like a bit of a simplistic way to break things down, and it's not always easy to define these kinds of problems. Do I have a museum versus am I in a museum? Like the relationship isn't always necessarily that clear. And the museum, I hope, doesn't have me, or we're in a really bad spot. So when we use inheritance, any change in a superclass affects all the subclasses, and sometimes this has unintended effects. So to avoid this in our course, we're going to stick to using inheritance with the shared public interface sense, and we're going to prefer that subclasses don't change public interfaces at all. So you don't change the interface of a public method. For instance, we're not going to add or remove parameters or change types, and we're going to try not to add new public methods or attributes to a subclass. But adding private attributes or methods is fine. As a general programming concept, inheritance has a lot of other uses, and you'll see a lot of this in the next course after 148, CSC207 software design. So last notes about this. It's not a requirement of Python that you override an abstract method, although in other languages it can be. However, it is a feature of the way we plan to use inheritance in this course. Other uses of inheritance, implementation can be deferred to subclasses of a subclass or something further down in other versions. Finally, for polymorphism, the roots of the word polymorphic polymorphism are poly, meaning many, and morph, meaning form. So polymorphic literally means of many forms.